Welcome. Today we are looking at electromagnetic waves. This is topic 3 in your SS2 physics series. This topic is common in objective questions in your examinations. Pay close attention. Let us begin. First, let me explain what electromagnetic waves are. Electromagnetic waves are waves that consist of oscillating electric and magnetic fields. They are produced by accelerated charges. They are transverse waves. This means the oscillations are perpendicular to the direction of propagation. Electromagnetic waves do not require a medium. They can travel through a vacuum. They travel at the speed of light. This is approximately 3 times 10 to the power of 8 meters per second. Electromagnetic waves carry energy. They carry momentum. Understanding electromagnetic waves is essential for understanding many physical phenomena. It is essential for understanding modern technology. Now let me explain the electromagnetic spectrum. The electromagnetic spectrum is the range of all electromagnetic waves. It is divided into regions based on wavelength and frequency. The regions from lowest frequency to highest frequency are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Radio waves have the longest wavelength and lowest frequency. Gamma rays have the shortest wavelength and highest frequency. The speed of all electromagnetic waves is the same. It is the speed of light. The relationship between wavelength, frequency, and speed is c equals f times lambda. C is the speed of light. F is frequency. Lambda is wavelength. Understanding the electromagnetic spectrum is essential for understanding the properties of electromagnetic waves. Now let me explain the properties of electromagnetic waves. Electromagnetic waves have several properties. First, they are transverse waves. Second, they do not require a medium. Third, they travel at the speed of light. Fourth, they can be reflected, refracted, diffracted, and polarized. Fifth, they carry energy and momentum. Sixth, they obey the wave equation C equals F times lambda. These properties are essential for understanding the behavior of electromagnetic waves. They are essential for understanding their applications. Now let me explain radio waves. Radio waves are the lowest frequency electromagnetic waves. They have the longest wavelength. They are used for communication. Examples include radio broadcasting, television, and mobile phones. Radio waves are produced by oscillating electric currents. They are detected by antennas. They can travel long distances. They can penetrate buildings. Understanding radio waves is essential for understanding communication technology. Now let me explain microwaves. Microwaves have higher frequencies than radio waves. They have shorter wavelengths. They are used for communication and heating. Examples include microwave ovens, radar, and satellite communication. Microwaves are produced by oscillating electric currents. They are detected by antennas. They are absorbed by water molecules. This causes heating. Understanding microwaves is essential for understanding modern technology. Now, let me explain infrared radiation. Infrared radiation has higher frequencies than microwaves. It has shorter wavelengths. It is used for heating and sensing. Examples include infrared heaters, remote controls, and thermal imaging. Infrared radiation is produced by hot objects. It is detected by thermal sensors. It is absorbed by molecules. This causes heating. Understanding infrared radiation is essential for understanding heat transfer and sensing. Now, let me explain visible light. Visible light is the part of the electromagnetic spectrum that is visible to the human eye. It has frequencies between infrared and ultraviolet. It is used for vision and illumination. Examples include sunlight, light bulbs, and lasers. Visible light is produced by excited atoms. It is detected by the eye. It is essential for life. Understanding visible light is essential for understanding vision and optics. Now let me explain ultraviolet radiation. Ultraviolet radiation has higher frequencies than visible light. It has shorter wavelengths. It is used for sterilization and tanning. Examples include UV lamps, and sunbeds. Ultraviolet radiation is produced by excited atoms. It is detected by UV sensors. It can cause skin damage. It can cause cancer. Understanding ultraviolet radiation is essential for understanding health and safety. Now let me explain X-rays. X-rays have higher frequencies than ultraviolet radiation. They have shorter wavelengths. They are used for medical imaging and security. Examples include X-ray machines and CT scanners. X-rays are produced by high-energy electrons. They are detected by X-ray detectors. They can penetrate tissue. They are used to image bones. Understanding X-rays is essential for understanding medical technology. Now, let me explain gamma rays. Gamma rays have the highest frequency and shortest wavelength. They are the most energetic electromagnetic waves. They are used for cancer treatment and sterilization. Examples include gamma knives and irradiation. Gamma rays are produced by nuclear reactions. They are detected by gamma detectors. They can penetrate tissue. They can kill cells. Understanding gamma rays is essential for understanding medical technology and nuclear physics. Now, let me explain the applications of electromagnetic waves. Electromagnetic waves have many applications. Radio waves are used for communication. Microwaves are used for cooking and communication. Infrared radiation is used for heating and sensing. Visible light is used for vision and illumination. Ultraviolet radiation is used for sterilization and tanning. X-rays are used for medical imaging. Gamma rays are used for cancer treatment. Understanding the applications of electromagnetic waves is essential for understanding technology and medicine. Now let me explain the hazards of electromagnetic waves. Electromagnetic waves can be hazardous. Radio waves and microwaves can cause heating. This can lead to burns. Infrared radiation can cause burns. Visible light can cause eye damage. Ultraviolet radiation can cause skin damage and cancer. X-rays can cause tissue damage and cancer. Gamma rays can cause tissue damage and cancer. It is important to use protection. It is important to limit exposure. Understanding the hazards of electromagnetic waves is essential for health and safety. Now, let me explain the wave-particle duality of light. Light behaves as both a wave and a particle. This is called wave-particle duality. As a wave, light exhibits interference and diffraction. As a particle, light consists of photons. Photons are packets of energy. The energy of a photon is E equals hf, is Planck's constant. F is frequency. Wave-particle duality is a fundamental concept in physics. It is essential for understanding quantum mechanics. Understanding wave-particle duality is essential for understanding modern physics. Now let me explain the production of electromagnetic waves. Electromagnetic waves are produced by accelerated charges. Accelerating charges produce changing electric and magnetic fields. These fields propagate as waves. The frequency of the wave depends on the acceleration. Higher acceleration produces higher frequency. Electromagnetic waves are produced naturally and artificially. Natural sources include the sun and stars. Artificial sources include antennas and electrical circuits. Understanding the production of electromagnetic waves is essential for understanding their generation and use. Now, let me give you sample exam questions. Define electromagnetic waves. Electromagnetic waves are waves that consist of oscillating electric and magnetic fields. State the speed of electromagnetic waves in a vacuum. The speed is 3 times 10 to the power of 8 meters per second. List the regions of the electromagnetic spectrum: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. State the wave equation. C equals F times lambda. Explain the wave-particle duality of light. Light behaves as both a wave and a particle. State the energy of a photon. E equals hf. Let me summarize. Electromagnetic waves consist of oscillating electric and magnetic fields. They do not require a medium. They travel at the speed of light. The electromagnetic spectrum includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Each region has different applications. Electromagnetic waves can be hazardous. Light has wave-particle duality. Understanding electromagnetic waves is essential for physics and technology. Practice these concepts. When you have them down, move to Topic 4.